Thank you very much, Emily. Hi, everybody. Thanks for joining us this afternoon. My name is John Goff. I'm the Senior Service Hydrologist at the National Weather Service here in Burlington. I'm joined by my colleague, Britt Westergard, who is the Service Hydrologist in Albany, New York, for the Weather Service down there. As Emily mentioned earlier, they cover the southern two counties in Vermont of Bennington and Windham. So if there are any specific questions at the end of the presentation that are addressed to those two counties, Britt may be able to answer those for you as well. Okay, let's go ahead and move on to the next slide. This is the general outlook for the presentation I'll be giving you today. We'll talk about, firstly, winter spring flooding climatology and causes. We'll talk about two highlighted events that cause flooding. We'll then move on and talk a little bit more about ice jams, the frequency of those, favored locations. Then about ice breakup and meltout scenarios when the ice is breaking up, what to look for. And as we wrap up the back part of the presentation, I'll talk about a recap of our current winter so far and the current spring flood outlook. Next slide. When we talk about winter spring flood climatology, it's most common in general in late February through early April. This is due to snowmelt and heavy rainfall, or just heavy rainfall only. Sometimes there may not be snow on the ground. River ice, if it's present, will often break up during these events, which can lead to ice jam formation. Now, I say late February through early April. Of course, in the weather business, there's always exceptions to the rule. So we can have ice breakup and flooding in January or December as well. And that has happened in some of the recent years here. It can happen, like I said, in early January or December. And here's some of the more recent events. The last year, we didn't have many ice jams that caused severe flooding in Vermont, but I do list the one in Ausable, New York, which is right across the lake in Essex County, New York, and that's a picture of that there on your right. Severe flooding did affect that village, and many homes were heavily damaged. But you can see some of the other events. We had a couple of them back in the winter of 1920 and 1819, and a few others back in time. As we deal with changeable climate, multiple or midwinter flooding events are becoming more common. Next slide. So when we talk about winter spring flooding causes, it's generally all about the rainfall. Things that we like to look for in the weather business of when we forecast flooding is to have a normal or an above normal snowpack. And what I mean by that is have a normal or above normal snow depth, and the same goes for water content in that snow. The water content will typically build up over time as the snowpack is compressed and slowly builds up through the winter. And the more water you have in that snow, the more water is obviously to melt as you come into the late winter and early spring and run off into our rivers. For ice jams, we look for substantial ice thickness, which we don't have a lot of right now, and I'll talk about that in a few later slides. And it's always this race up between the breakup of the ice and the melt out of the ice naturally. So we're always kind of playing those two against one another to see if it'll behave itself or not. The causative event is usually a significant warm up. It promotes rapid snow melt to increase river and stream flows. And it also, with those higher river flows, it has the ability to lift the ice up, move and break up the ice, which can lead to those ice jams. Heavy rainfall is the primary driver of these events. You typically need a heavy rainfall event to fall, either on bare frozen ground or on snow that will melt to cause flooding. If it's just the snow melt alone during March sugaring weather, when you have highs in the 40s and it's just gradually melting off through time, that typically isn't enough to cause the streams and rivers to really flood in a high degree. Next slide. So I'm going to go through two recent high impact events. We have a mid-season heavy rain and snow melt and ice jam event. Many of you may remember this from January of 2018 versus an end of year type of event in April where we still had some mountain snowpack and we had thunderstorms with torrential rain on top of that, and we lost it all basically in about 6 hours of the remaining snowpack. Next slide. So this is the ice jam flooding and open water flooding event of 2018. This is a pretty large scale weather event. We had widespread 1 to 2 inches of rainfall reported across the state. There's the map of the rainfall only. And then we had about 8 to 16 inches of snow depth loss, which equivalated was equivalent to about 1 to 2 additional inches of water into the system. So if you add that up, that's 2 to 4 inches of essentially rainfall. Snowpack did remain, especially in the mid and high levels of the Green and Mountains and Taconic Mountains and places like that, but a lot of it was greatly diminished. Next slide. Here are just some pictures around the area that experienced flooding. Lamoille River was particularly hard hit. There's the picture in the upper right of the Sterling Market there in downtown Johnson, where the Gihon comes into the Lamoille. And there's a couple other pictures toward the bottom. One of those in the lower right, I believe, is Swanton, which was also heavily affected by an ice jam, multi-day ice jam with this event. Next slide. This is the other event I mentioned. This was a thunderstorm torrential rainfall event on melting snow. So this was a corridor across south central and southern Vermont of 1.5 to 3 inches of rain. This was in mid-April of 2019. Again, about 8 to 16 inches of snow depth lost from the high elevations. We basically lost everything that was remaining at that point, and perhaps an additional 2 to 3 inches of water input into the watershed. So we had about a 3 to 5 inch rainfall event when you add that up. This was primarily open water flooding, so all the river ice had been, excuse me, pushed out of the rivers by this point. So we weren't dealing with any ice, but we had a lot of open water flooding due to the snowmelt and rainfall. So Otter Creek hit major flood level, and we also had some impacts on the Winooski, Passumpsic, and Wells River, and there was some flash flooding noted. And there's the map on the right showing the rainfall totals ending in the morning of the 15th of April of that year. Next. This is a corresponding plot of how much snowfall was estimated to be melted. So you can see in the blue colors there in the high terrain, somewhere between 2 and 3 inches of snow was melted out of those high terrain areas, and that also ran into those area streams and rivers. Next. Here's a map of the significant impacts from high water, and some of this comes courtesy of Vermont Emergency Management. There was significant damage to some roads and bridges, mainly across south central and east central Vermont. The color scale there, blue, yellow kind of color, and red is flood warning areas, high infrastructure damage, and major infrastructure damage in the red. And the town road closures and state road closures are kind of highlighted by the little stars. And we've got some of the National Weather Service flood warnings and flash flood warnings denoted by those green and red boxes down there. There is a still ongoing FEMA federal disaster, mainly for public assistance. It's DR 4445. I believe that's still in existence right now, based off of a lot of those areas that were affected by this event. Next slide. And these are the counties, the map of that DR 4445 affected by the event. Again, mainly south and central Vermont. Next slide. Here's a few snapshots similar to the earlier event I showed you of the open water flooding. I just took a few. There's a swift water rescue down in Rutland area. Weston, Vermont, down on the Windsor-Windham County border, had some pretty good flooding. There's the White River and Stockbridge. Stockbridge being a fairly well-known flood-prone area. Next slide. Okay, let's move on out of those two event summaries to a little bit more about ice jams. First, let's talk about ice jam frequency in Vermont. The majority will occur in mid to late winter, kind of similar to when we talked about the ice breakup and flooding threat time period. It's mainly due to midwinter or late winter thaws or the spring breakup. There can be freeze-up jam flooding focused in earlier winter when the rivers freeze up rapidly, let's say during an early Arctic air outbreak. Those are becoming less and less common this winter. Case in point, we haven't had much cold weather at all by Vermont standards so far this winter. It's been pretty incredibly mild. Over 40% you'll see there in the green pie chart there occur in March. And in general, central and northern watersheds are more favored than the far southern counties, but that's not to say they can't occur there as well. It's not so dichotomous that it's all up north and none down south. It's just a little more up north and down south. Next slide. Have an ice jam dashboard that we track current and active jams. Currently, there are no jams in our region. I did river ice surveys just yesterday and confirmed that. The blue circles and dots are basically an internal database that shows historically where ice jams have occurred in the past, the larger circles denoting where more have occurred at that single location. So a larger blue circle may be 2, 3, 4, 6 ice jams have occurred through history of that jam. And the database that's maintained by the Army Corps of Engineers for Vermont, at least, goes all the way back into just post-colonial times. We have ice jams in our database back to the late 1700s. So it's a pretty robust database. You'll see kind of a little bit of gaps here and there in northeastern Vermont, and not that we're covering New York, but in the Adirondacks, that's basically due to lack of population in a lot of those areas reporting things. Next slide. So when we talk about favorite ice jam locations, there's a few points just to keep in mind and places to look for them. It mainly is due to restrictions of flow in the river or creek channel and channel slope. And so you have to think of where, to boil it down, where does the river slow down? Think of a traffic jam. You know, most causes of traffic jams are people changing lanes and volume of traffic where people have to slow down on the roads. It's the same thing in a river. When the channel goes from a steep slope to a flatter slope, the general speed or current flow in the water slows down. And it's also slowed down due to restrictions in the channel. They can be man-made or natural. So if you think of man-made, it's something like a bridge abutment or a highway overpass that comes over, or a dam, for example. And there's a couple examples I show here of the changes in that. They can also be natural. So like an oxbow in a river. So a big oxbow, like in Newberry, Vermont, where you have the big oxbows there, can be sometimes a favorite location for that. Next slide, please. The United States Army Corps of Engineers does have assessment reports, and National Weather Service river ice surveys help confirm and support some of these assessment reports that have been made. Ice jam histories and mitigation assessment and strategy reports, that's a tongue twister, are now available for the towns of Johnson, Swanton, Coventry, and Linden. We gave talks with members of the Corps last year to those towns, so some of you may have sat in on a few of those talks. Those are available, and if you're interested in receiving the reports for those towns, my email contact will be shared at the end of this presentation. You feel free to reach out to me and I can get you those documents. It's a pretty comprehensive, and it's basically a mitigation report. Basically, what can the town do and suggested strategies if you're concerned about ice jams in these towns? What are some options? Certainly, you know, nothing is free. These things do cost money and would require town and in some cases state level budgeting, but those reports are available. And again, I mentioned river ice survey. So I do these bi-weekly from Burlington, Vermont, mainly on the northern 4 rivers, since they typically are closer to home here and they're a little more ice prone than the far southern rivers. So I do the Missisquoi, Passumpsic, Lamoille, and Winooski, and I assess current conditions on that and note the degree and coverage of ice, note any ice jams, and we'll place those in that ice jam database for us to keep situationally aware of those in-house and to pass that on to needed partners. Next slide. When we talk about ice jam and ice out scenarios, there's 2 main ones. We have a thermal or a melt out. When I think thermal, think about like melting by the sun and to a lesser degree, warm temperatures. And then the mechanical wave ice out, where the river is really high due to runoff and melting and it breaks the ice up mechanically. Next slide. So how do we define midwinter thaws when we talk about potential for ice breakup? Here in the Weather Service, we want at least about 12 hours above freezing, and particularly, and more importantly, a little bit of time above 40 degrees. You know, if you're just counting 12 hours and it's 33 or 34 degrees, it doesn't really add up to much. But if you're above 40, we can kind of track how many hourly temperature degrees are above freezing in a nutshell, and it can greatly enhance the potential for breakup. If you have daily average temperatures above 42, that's the average of the high and low, divide by 2, it's above 42. That's another good indicator. And it does take time for thaws to impact rivers. So if it's a very, very brief warm up and we just hit 42 degrees for an hour or two and then crash below freezing, it will not have as much impact as the case of where you're above 40 for like a whole day. And so if these things are greater than a day, 1 to 2 days, the threat is greater. Next slide. Here's the scenario of mechanical breakup. This is the picture of an ice jam at Au Sable Forks back in 2018. The river is totally out of its banks. It's flooded the right side of the river channel, denoted by the trees there. I've got a pretty interesting movie that shows the ice jam in effect. I didn't want to share it here due to bandwidth potential issues, but it's an excellent movie to see how ice can form quickly, move downstream, jam up, and flood an area. We need significant river ice thickness, an extended period of freezing temperatures that limit thawing. So we got a thick ice cover in place, and then you want a sudden increase in river flow. Generally heavy rain and snow melt. You can have ice breakup or water running up over the ice. Snow melt, and that shouldn't be a long, it should be a lone, usually doesn't do it. You generally need a more substantial rise due to snow melt and rainfall. And from a very rough rule of thumb, and this isn't completely true all the time, but a very rough rule of thumb is you want a river rise 3 times the thickness of the ice. So if you got a foot of ice, you want the river to come up 3 feet or so to potentially break it up. The river is very elastic, and so small river rises, it'll just kind of bow and flex and it won't necessarily break up, but a big one can break it up. And then again, you want to look at favored ice jam sites. There are favored ones we know of around the state. There's always a few whack-a-mole scenarios where one will pop up that we've never seen before. But in general, there are favored locations. Changes in channel slope, the intact ice cover breaks up and then it runs into an impediment. The ice stops moving and blocks the channel, and then you get the flooding. Next slide. A couple other points for midwinter ice jam breakups. As cold weather resumes, old jams may settle in place once the water recedes, and they could serve as a focus for future breakup jams by late in the season. That has happened on several occasions in my 23 years or so here, just knowing that type of scenario. So if they freeze up in place and the water subsides, pay attention to those old ice jams because they are still a clog in the channel if the river rises again and more ice can come downstream. Next slide, please. This is the thermal melt out scenario. This is your best scenario. This is where you have not a lot of heavy rain or rapidly melting snow. You just have gradually melting snow, mild sunny days. Think March, cool sub-freezing nights, good sugaring weather. Long duration, gradual warmth with no significant rainfall. So the ice cover thins and weakens and melts in place over time. There may be a few minor jams, but generally we're not looking at anything of a major degree. The important point here is solar radiation is the biggest role player in ice breakup. It's not necessarily warm temperatures. That has a small degree of impact, but the solar radiation, as the sun gets higher in the sky, and we've turned the corner now in January, a month from now, you'll definitely start to see the difference in the sun angle. That's the biggest role player. It tends to rot the ice. You start to get these open channels. The ice tends to break up and kind of break off into these little sheets, as you see here from a picture in East Montpelier last year I took. Sometimes if there's a big jam in place and they're worried, you can do mitigation efforts. Some communities have opted for that strategy in extreme cases. I believe the year was 2012, about 10 years ago or so, the city of Montpelier did use a couple of emergency options to break up a jam that was in place in the winter there. And they used some emergency actions through state level management to run, I believe, some sewer effluent water into the Winooski River there, which is warmer water. It's kind of against EPA rules, but under emergencies, you can do that. It can help break up the ice. I think another option they explored was leaf debris or dusting, which they'll pour old leaf debris or soot on the ice, which is a dark color, and that'll tend to absorb the heat of the sun and get hotter, and it'll tend to melt the ice from above. Next slide. So now let's move on to the current. We're going to talk about the winter recap thus far and the winter spring flood outlook. Next slide. This is the overall flood outlook summary. Again, this slide is only for the next week. These are issued bi-weekly by our Northeast River Forecast Center and then updated every 2 weeks. So it was updated last Thursday. So this is about a week old. But the current going out through about February the 3rd, the first week in February, the river flood threat spring flood threat is below normal for open water flooding, and it's definitely below normal for ice jam flooding because there's hardly any river ice out there. The long-term threat, I never get too cute with trying to get too crazy with this because things can always change quickly. Right now, I'm saying that's near normal for mid-March. I'm going to show you a couple of slides here in a moment. The current conditions is a near to below normal snowpack. I do put an asterisk there because we've gotten into an active pattern and we are slowly making up for lost ground in December and the first part of January. But we have much below normal river ice thickness. I did surveys on the Lamoille, Passumpsic, and Missisquoi yesterday. The only river with any considerable ice is the Missisquoi, and even on there are large stretches of open leads. There are no ice jams. The Winooski is wide open except behind a few power dams, and that's the same on the Passumpsic except for a small, about maybe 3/4 of a mile to 1 mile stretch south of the Price Chopper there in Linden, between Linden going south towards St. Jay. There's a little sheet ice, solid ice cover there. Otherwise, the Passumpsic is wide open, including where the Moose River comes in there to the East Branch. So that's kind of the current conditions. The greatest threat to flooding is above normal rainfall, as I mentioned, or a sudden warm up and melting. And so you always want to keep abreast for future forecast river ice conditions and any briefings that the National Weather Service in Burlington or Albany will send out on these events, because things can change quickly. Again, we'll have another update in about a week. Right now, looking at the long term, I don't see any large scale warm up in the models out for the next 2 weeks that would indicate even beyond February 3rd there that I'm overly concerned through, let's say, the first week to 10 days in February. Beyond that, it's kind of fantasy land, so we don't know yet. Next slide. Again, a little bit of the meteorological winter so far. I'll highlight just Montpelier here. The graph here is taken from the normal highs and lows, with the kind of dark yellow band being the normal range. The blues and the reds are above normal or below normal, with the top and bottom of that being the extremes, and the blue bars being basically the highs and lows in Montpelier since early December. And you can see even the majority of it's either been normal to well above normal. In fact, Montpelier, I think, is running about 12 to 13 degrees above normal for January, which is one of the warmest on record. It hasn't been particularly earth-shattering on the daily highs, but we haven't gotten cold at night at all. I'm sure many of you woken up in the morning and you're like, heck, it's 25 degrees outside and it's cloudy. A throwback, a feedback of that being milder is we've had more moisture in the air and it's been cloudy, so we haven't seen the sun in like forever. But that's kind of a very telling graph there, and it speaks largely to why we're not seeing a lot of river ice right now. It's been very mild. Okay, next. Here's our current snowpack conditions. This was just from yesterday. You can see the snow depths generally are 6 to 12 inches in the valley, 8 inches to 2 feet, mid-level terrain up to about 2,500 feet, up to about pass level, App Gap, Lincoln Gap, those kind of areas, Roxbury Gap. Higher terrain and summits are about 1.5 to 3 feet. And these graphs typically, when I put these out, I also include New York, but Vermont's kind of the same. For your snow water content, for your valleys, it's 1/2 to 1.5 inches. Mid-terrain is 1.5 to 3 inches, and 3 to 5 inches at the summits. That's about normal for the valleys and below normal for the mid and high terrain. So it used to be way below normal, but we are kind of creeping back slowly to normal. We've got a snow event tonight, and we still have a fairly active pattern with some light snow events all the way out into next week. So I think by the time we come around to another week or two, we're even going to make up more of those deficits that were accrued in December and the first part of this month. Next slide. This is a this is a plot of the snowpack current conditions of the snow water equivalent. So this is how much snow water is in the snowpack. Highlighted Vermont there. This is from the National Operational Hydrologic and Remote Sensing Center out of Minneapolis, and they make these plots for the nationwide. I don't have a zoom. I'm working with them to try to get a raster file available so we can have a Vermont customized zoom option, but I had to kind of just zoom in myself and highlight it. The main points here for the SWE, near normal or so for the broad valleys on your water content. More importantly, in the high terrain, it's near to maybe a little bit below normal in your southern greens, and your northern, central and northern greens are still lagging a little bit below normal. And so that's those kind of plots I tend to look at, and we look at these closely as we get into the later part of winter to assess the potential for melt and flood potential. Next slide. Again, I've touched on this already quite extensively. The river ice coverage is minimal. This was in St. Jay just yesterday. It's basically no ice. There's a little shore ice out there, border ice, I would call it. A little bit of kind of ice in the middle of the channel floating down, but largely the channels are wide open. And so right now, there's no ice jams noted in our area. I don't see any major problems. Again, you know, you can always be surprised by ice jams. Something can happen weird, but right now I'm not looking at anything comparable to any of the big events I had shared with you early in the presentation, like the 2018 event. Again, the highest coverage is on the northern watersheds, such as the Missisquoi, and even here, there was considerable open water along Route 105 and some of the areas up there going toward Richford. Next slide, please. It's our current stream flow state. As some of you may have noted, we were in some abnormally dry conditions, and earlier in the fall and summer of last year, we were in some slight drought in parts of the state. That's all been obliterated. I've got a coverage slide on the next slide here. All of your latest stream flow stats from a few days ago are above normal. So right now, while it's not a concern, if this were the case, for example, on a big meltout event and your streams are already above normal, then that would be something to consider for flooding. But right now, no big concern. Some of the grayed out dots are just basically data that's not really that reliable. Okay, go ahead. Here's Lake Champlain. We're running above normal. For this time of year, flood stage, as many of you know, is 100 feet. Our normal crest is in basically early May, about middle of spring. There are no immediate concerns for Lake Champlain. Lake Champlain is a very slow responder, and even if we lost everything all at once, it wouldn't necessarily mean Lake Champlain would flood. You need a lot of prolonged, heavy rainfall, occasional moderate rainfall, a very wet spring with snowmelt to cause any kind of thing of concern. And so we're not looking at anything right now, but we are running above normal. So we do keep an eye on that. And those are the plots going out through time. And we will keep you abreast should anything draw alarm if we get later into winter, especially into early spring. Next slide. I mentioned the drought in Vermont. This is the National Drought Monitor Map for Vermont. This was valid. They update this every week. This is an older plot from January 19th. I don't have the latest plot, but it's basically the same this week. There's no abnormally dry or moderate drought conditions in Vermont anymore. There were some in a neighboring New Hampshire across the border in Sullivan and Grafton County, New Hampshire as well, but that's all gone now. So they've been alleviated, and right now, given the active current pattern and the slow building of the snowpack, I can't envision that coming back at least any time in the next month or 6 weeks. You know, when we get into spring, if we do evolve into a dry pattern, then we can reassess at that point, but no real water concerns at this point. Next slide. I do want to remind everybody it's still winter, even though we're about to creep into February next week, and about 35 or a third % of our snowfall does occur after February 2nd. And as some of you remember, we can have some big snowy marches. I believe 2001 was a huge one. We had about 50 inches up here. So it's not done yet by far. The winter tends to go in and out of these active cycles and kind of quiet cycles. Right now, we're in an active cycle. Right now, looking at the long-term plots, it looks like we tend to trend quieter as we head toward Valentine's Day for at least a little bit. So that's probably good news not to get too much built up, only a gradual built up. But again, we've got a ways to go until we're totally clear of this. Next slide. These are the 8 to 14 day outlooks. Basically, these are updated frequently by our national climate centers. The latest guidance going out through the first week in February, I kind of mentioned earlier in the presentation, there is some indications that we may tend to creep below normal for at least in temperature wise for at least a multi-day stretch, probably for the first time all winter. And I looked at some of the plots this morning off of some of the more reliable data, and I would tend to agree with that. I don't think we're looking at extended bitter Arctic cold, but maybe colder than we have been. And so that's something to keep in mind. We probably are going to see a little more river ice formation during this time as we move forward into the next 2 weeks. And I mean, we haven't even been barely below 10 degrees in Burlington all winter, which is crazy. I think 8 degrees is our lowest temperature all winter. And I was chatting with Britt, the hydrologist, my colleague down in Albany yesterday, about the river ice, and it's remarkably low. The 8 to 14-day precipitation outlook, we're kind of teetering on the line of, normal to above normal. And so again, that's all kind of subject to change. One big storm can change that, and these are kind of 1 to 2 week outlooks. So you just kind of take that a little bit with a grain of salt. These are the general outlooks. Right now, looking at the models I've looked at, I didn't see any big blockbuster nor'easters out there, but I do see some frequent bouts of light to occasionally moderate snow affecting the area. Next slide. All right, we're about ready to wrap up here. I just want to remind you, there's my contact information and my our office phone number. That's my email. Go to me directly, and the number goes into our operations because I'm not here all the time. That will ring to operations, and a forecaster will help answer your questions for you if you have them, or if I'm here and you want to speak with me during generally business weekday hours, they can patch you through to me. And there is Britt's contact information down in Albany, again, for the southern 2 counties of Bennington and Windham, if you have a particular question that addresses those 2 areas. Next slide. Okay, that's basically all I have. I'm free to answer any questions. This is a typical slide we also share on a lot of our briefings that we give out for impact weather events like we're doing right now for this upcoming snow this evening. So we do have a presence on social media. You can contact us through that number as well. And there's some of our information also there displayed. That is all I got. Thank you for your time.
Thank you, John. So we've now gone to the Q&A portion of our National Weather Service presentation. Please either raise your hand or put a question in the chat, and once I get through those, I'll open it up for anyone who can't do either of those to allow them to unmute their mic. So we'll start with a question from the chat from down in Windham County, so I don't know if Britt would rather answer this. The question is, curious if there's any correlation between La Nina and El Nino conditions and the frequency/intensity of spring flooding. Britt, is that something you'd like to answer?
Oh, I can leave that for John. That's fine.
Okay, go ahead, John.
Yeah.
Yeah, La Nina and El Nino are generally Eastern Pacific climatological phenomenons. Basically, when we talk about New England, there are other atmospheric kind of long-range climate signals that we look at. I will be brief here, not to get too technical, but basically there's something called the North Atlantic Oscillation and something called the Arctic Oscillation, which are much closer to home. The North Atlantic Oscillation affects weather regimes across the North Atlantic. Think east of New England up into the Canadian Maritimes, Greenland, Iceland, and also the Arctic Oscillation up in the polar areas that can affect cold air or the lack of coming down. Those 2 have a much larger influence on our weather. The difficulty I will say in those is those climate signals change on the order of just a couple of weeks, while El Nino and La Nina change over more like monthly, seasonally. In the case of right now, we're in the 3rd year of La Nina, yearly timescales. But in terms of the research that's been done and the signals compared to those, they have a much less impact on our degree of weather influence and spring thaws across all of our region in New England. Not to say they have no influence, but when I look at weather patterns from a climatological signal, I'm much more often looking at those other indices I just mentioned to come up with an educated guess on what may happen in the long term, not El Nino and La Nina.
Thank you. And Chris Campany, I'm seeing your hand raised. Do you want to follow up on your question?
Actually, it's a little different question. Can you hear me okay?
Go ahead, Chris. Yeah.
Okay. Well, I know that when Burlington sends out its alerts to the emergency list, Vermont Local Roads picks that up. And I know you guys always say this covers all of Vermont, including Windham and Bennington County. But of course, we also pay attention to the alerts down here that come out of Albany. I'm just curious, internally, communication-wise, like if Albany is seeing something that Burlington should see, or I guess vice versa. I mean, do you guys like reach out to each other? I'm just trying to figure out as far as like working with our towns and internally here at our regional planning commission and with our EMDs, just like what the communication is like between the 2 offices.
Right. Yeah, absolutely. Strong internal coordination on both offices. We also border Gray, Maine Weather Office in New Hampshire, and a little bit of Buffalo out by New York. Yeah, very strong internal coordination. The one point to take away is from us in Burlington is we are the state liaison office, weather office for Vermont, and Albany is for New York. And there are multiple weather offices in New York. So when we go out and do a brief, while Albany also does a brief for their southern counties in Vermont, they're sending it out to their Connecticut and New York and one Massachusetts county as well. The main takeaway is we want to generally be on the same time frame of when we're putting out, for example, winter storm watches or a flood watch. And for a case like this where we have snowfall maps out, we generally put out a map for the whole state, which is coordinated with Albany. So we have the same picture, because there may be some users outside of just Bennington and Windham where you are, such as state level emergency management, that wants to see the state as a whole, and they don't necessarily want to see just our area, if you know what I mean. And the same would go for other offices that have just parts of state. Some of the state level and federal level monitors of these things want to see the state as a whole. But no, you're very right. There's heavy internal coordination. And if we see something when we're doing the forecast that's starkly different from what Albany has, we will chat. We have an internal chat mechanism, or we can even pick up the phone and just talk to them in person, and we'll get more in line. The weather's not perfect. Sometimes you may see very minor differences, and some of that may be a result of how the plotting schemes work on the mapping, but generally that's how the process works.
Thank you so much, John. Next, we have a question in the chat. Is it expected with climate changes that we will see more winters like we are experiencing now?
Yeah, the climate change questions, those are always difficult, right? Because it's totally hard to tell. One thing I will, and positive to say, if you look at the long-term trends and the winters here, they're milder than they were before. And by far the driver, and this winter is a classic case, by far the driver of that, at least looking in Burlington's area weather, of long-term stations that have had periods of record that go back 50, 70, 100 years, is you're not getting as cold at night. And that's driving the overall average winter temperatures higher. We're not necessarily seeing tremendously brutal heat waves more than they did back in the 30s and 40s, for example, that were very hot decades. There are some hot days. Those trends and high temperatures are ticking up slightly, but not as much as the overnight lows. And this is a great winter. Case in point, we haven't even been below zero in Burlington this year. And even 20 years ago, those are very common to go below zero in Vermont. We haven't had much of that. That's driving that and keeping a lot of these nights cloudier. So the long term, if you just want to just think, objectively about it, if the winters are getting milder, there is a natural result is there's less ice on the rivers. The rivers are harder to freeze up than ponds and still bodied waters like lakes anyway, because the current is moving. And so you're always going to have to get colder than just freezing to freeze those rivers up. So no, that's a natural conclusion going forward 30, 50, 60, 100 years. If you believe some of the models that are out there, we can expect more of the same, if not more frequently. Although each winter will be different, maybe it's milder later and a little bit colder sooner. It manifests itself in different ways.
Thank you so much, John. Seeing no more questions in the chat or hands raised, if there's anyone who can't do those functions but would like to ask a question, please unmute your microphone now and I will call on you. Okay, seeing none. If you do think of any questions in the future, remember we are going to have those regional Q&A sessions the second week in February. I'll be sending out information reminding folks about that tomorrow. And National Weather Service will be there providing an update to this presentation a bit shorter and focused on just that region. So thank you so much, John and Britt, for being with us today. And we look forward to seeing you in a couple more weeks.